This is your last time for voting. My calculus class, all seniors, is trying to talk me out of giving them a final exam this year. So please vote on this, and I'll show the votes, the comments to them, and so you can you can force them to take the final. They're begging. All right. So here's this finding the derivative of a log function. First thing I'm going to do is this, Kim. I'm going to take this and I'm just going to rewrite this like this. I think we can agree that this is true, isn't it? Right? To the 1/2 power. And this what I'm about to use here is not a law of calculus. It's a property of logarithms, right? And we know that if we have log base a of x to the n, we can rewrite that as n log base a of x. That is to say, we're allowed to roll this thing back as a coefficient. So that's what we're going to do here. We're going to take this and just roll it back to here. This is not me differentiating. It's just this, yeah? ln x plus 1 over x minus 1. And then using the properties of logarithms that we already know, we also know we can do this. So I'm going to take this 1/2. This is a little bit important here, though, because we have to keep this to the quantity here, don't we? I'm just going to break this out. We have, right, if we have log base a, I'm not even going to do it. You guys should know this rule, right? Is ln of x plus 1 minus, right, this division sign is minus, so minus ln of x minus 1. Again, this is not differentiation. This is just using properties of logs, right? Now I'll start to differentiate. So now we'll differentiate this. This 1/2 is a constant multiple, isn't it? Times, well, what's the first derivative of ln of x plus 1? Yeah, 1 over x plus 1. Remember, the derivative of the inside is 1. That's why there's nothing on top. Minus 1 over x minus 1. We're using the chain rule here. It's just that the derivative of the inside is 1, so it doesn't look like anything. So far, so good? This can be cleaned up if you wanted to. And the way I would clean this up is this. I would multiply this side by x minus 1 over x minus 1. This side by x plus 1 over x plus 1. And that would give you 1/2 x minus 1 minus, right, x plus 1. To be really careful here. But this is what your professor is going to expect you to do, so you might as well see it. It'll probably be on the final exam. You know, they're going to vote. They're going to vote. They're going to vote for you guys to have one. I'm going to distribute. I'm going to say it again. This negative sign right here is this one right here, right? So I bring this, and this goes to negative, and this goes to negative also, doesn't it? Is that all right? Does that make sense, Greg? X minus x is nothing, but negative 1 minus negative 1 is negative 2. But we have 1/2, so it's negative 1 over x squared minus 1. You don't have to go that far, and I was saying before that depending on which calculus you take in college, if you take applied calculus, the more difficult one, you won't have to do as much algebra because there won't be time for it. You'll be applying it to really sophisticated problems. If you're taking business calculus, you will have to do more algebra. All right? Remember to vote.